Hi Kieran, nice to hear from you. I hope this is helpful. So there's a few ways you can maybe go about it, but there's definitely an easy way that I'm going to use anyway. And basically it's this idea that if I've got an equation of a tangent, then I know that that is y equals mx plus c. And from the diagram below here we can see that there are two possibilities. So there are two different gradients, and therefore there are going to be two different y-intercepts. So basically what we're going to try and do is use some of the stuff you did right at the start of year 12. Is I want to know when this tangent, the y equals mx plus c, crosses or just touches the circle. So I'm going to form an equation, but the trick is to write what c is in terms of m, and then that just makes the algebra fall out a lot nicer. So using this information, I can make my y equals mx plus c, I can substitute that point in, so I know that I must get 3 is equal to negative 4m plus c. Now that gives me the relationship between m and c, which is going to be really useful. So if I just very quickly rearrange that, that means that c is going to be equal to 3 plus 4m. So now I've got this relationship here, I can work on using y equals mx plus c and x squared plus y squared equals 5 to try and solve it simultaneously. So if I substitute it in, then I get this equal to 5. And I know you're thinking, here we've got 3 things that we don't know, which is a bit tricky. But we're going to be able to form an equation later on, because we know that if it's a tangent, if we can form a quadratic, which it looks like it will fall out, we know that b squared minus 4ac is equal to 0. So that's going to help us to form a third equation to find those 3 unknowns. Okay, so let's just plough through this a little bit. We've just got to expand that line, so we should have x squared plus m squared x squared plus 2 lots of mxc plus c squared equals 5. Using this relationship, I've got to try and now get a x squared term. Well, there we go, the first 2 factor out nicely, and 1 plus m squared is going to be its coefficient. 2mc is going to be my x term, and c squared minus 5 is going to be my plus c. I know I've used c twice there, but that's just the way it is. So if we substitute these into the discriminant, sub into this equation, then that's helped us to reduce it down so that we've only got m's and c's. So we've got rid of one of those things that we didn't know. So if we do that, we get 4m squared c squared minus 4 1 plus m squared c squared minus 5. And I know what you're thinking. You're probably thinking, oh, okay, but we've still got m and c in this equation. But remember, right at the beginning, because we knew which point it went through, we have another substitution that we can make, okay, which is here. Now, from experience, just doing problems like this before, I know that it's usually better to do the expansion and see if anything cancels out, and then make that substitution. So that's what I'm going to do, and usually there's some kind of grouping that can help us. So when we do that, minus 4, we get c squared minus 5 plus m squared minus 5 m Yeah, good. And then if we just tidy that up a little bit, or just missed a squared there, sorry, my mistake. But we can see that that works out nicely with that term. Minus 20 plus 20m squared equals 0. So they cancel nicely. And just like I said a moment ago, that makes it much nicer for me to make my substitution now. That's a weird 0. So if I do that, and make that, I can't remember what it was, 3 plus 4m. Yeah, and really I think from here you could probably take over actually, because as soon as you've got that value of m, then we should be laughing. So if we do a little bit of work here, we're going to have minus 4, and then 9, 24 lots of m, plus 16m squared, plus 20, plus 20m squared is equal to 0. And if we tidy that up, we should get 44m squared minus 96m minus 16 equals 0. They've all got a common factor of 4. So we can get to here. And then, maybe it, yeah, I think that factorizes. So I'm thinking, yeah, minus 2 and m, or not probably minus. Okay, I'll just double check that. So we've got, yeah, that works. So there you go. So I've got my two gradients of m being 2 over 11 and the other being, oh, not x, the gradient being equal to 2. Yeah, and as soon as you found those, you can substitute them into here to find your plus c's. Alright, so that should give you both of the equations of the tangent, but the trick really is to try not to substitute in this until you've done a little bit more manipulation. It just falls out nicer. Okay, I hope that helps. Any more help I can be, yeah, just let me know. All right.